everybody. My name is Yakov Fain, and we'll talk about Angular for Java developers. I'm a Java developer myself, so it's going to be easy for us to understand each other. First, the legal slide, of course, as Oracle teaches us, and then a couple of words about myself. I work for the company called Farata Systems. It's a consulting company, and I do everything related to Angular these days, or in that company. This is my recent book. I wrote it with my colleague, and discount code if you want to get it at Manning. At the end of the presentation, on the last slide, you will see the link to this slide deck, so you don't need to take photos or anything, so the slides are already up there. So what do we talk about today? I'll give you a big picture of what is Angular, and I'll show you a couple of demos, and then we'll start a simple Spring Boot server and deploy the Angular app in there, so we'll see how Angular talks to Java. A couple of demos will be there as well. So, but first I want to give you a big picture. 2 years ago, Google decided to rewrite a super popular framework called AngularJS, or these days they call them Angular 1, AngularJS 1. And they did it in the language called TypeScript from Microsoft. And the other contribution from Microsoft is the library, RxJS. Actually, it's not like that Microsoft created this library, but they created first library with reactive extensions, rx.net, and then it was ported to many languages. And Angular 2 was released in September of 2016. When I submitted this proposal for this talk, it was 2, and tomorrow the next version, Angular 4, will be released. So that's why I changed the title to Angular 4. But every 6 months, Angular team will be releasing the next version, which is upgrade is seamless, easy, so don't get scared by all these numbers. Angular framework has an excellent dependency injection model, and I'll show you how it works. I'll have an example. Then you can write application in Angular using any of these languages like TypeScript, Dart, or JavaScript. But TypeScript is a recommended language for writing Angular applications. And it makes sense, and I'll show you the language, and it will be very comfortable for you being Java developers. What about UI? Are there any libraries for Angular with UI components, which is very important? So Angular team is working now on the library called Angular Material 2. I'll show you some of the components. It doesn't have too many components these days, but there are third-party libraries. For example, I like the library PrimeNG, and we use both Angular Material 2 and PrimeNG. What else is great in Angular? They have separate rendering engine. So when the piece that renders HTML can be replaced, not by you, but by the companies who are developing software. And there are already frameworks to render UI not as HTML, but you can create applications for mobile devices. And for example, there is native script. They are replacing the rendering engine. So instead of HTML, you'd be rendering their tags, which are mapped to native components on the mobile. Plus tooling. Tooling is great. In terms of tooling, you have a bunch of different IDEs that support TypeScript and Angular. I'm using products from JetBrains, usually. Like I was using IntelliJ IDE, and now I'm using WebStorm. But there is another great IDE called Visual Studio Code. It's free, and it has excellent support of Angular. In terms of deploying, there is a great tool. Actually, this tool generates the application and allows you to deploy and bundle and everything. So this tool is called Angular CLI, and it has inside other frameworks, and in particular, it uses Webpack for bundling. How do you start? When you have a picture like this from your web designer, that you need to create a front end for the online auction, for example. So what do? You ask yourself, what components do I need to create? Angular app is a bunch of components. You have a root component, children, grandchildren, and so on. So if you look at this picture, you identify the components that you want to create. Like in this example, I have a navbar component. Up on top, at the bottom, I have footer. On the left, I have search component. I have product item components. Each of them would render one product, right? I have some carousel and so on. So this is what you need to start with. You need to ask yourself, which component do I create? And how the code looks like. When you will be developing this UI, the UI portion will look like tags, like HTML tags. If you look on the right, these are HTML tags. Not all of them are standard HTML tags. Of course, there is div. It's a standard HTML element. On the other hand, you see auction navbar, or auction search, or router outlet. All these things are yours, or Angular's. So for example, if you will create a class and you will give it a selector named auction navbar, then you can use it in angle brackets as a template. But behind this tag, there is your component. In this example, router outlet is a directive that comes with Angular. So router is something that allows you to navigate on the UI. On this screen, you see this navy blue area. We have a single-page application, but we assign one or more router outlets, and the content inside of these router outlets can change based on, say, user actions. So you can show either this component or that component within designated area. And the class represents a component, a class annotated with special decorator. In our world, it's easier to use the word annotation, right? So let's take a look. We have a class app component, which is annotated with the annotation at component. Inside this annotation, you say, what is a tag that you want to use on the UI? Selector, app root. Where is your HTML? If you have a lot of HTML, keep it in a separate file. If you have small HTML, keep it inline. Do you have styles? Do you have CSS files? Where are they? Specify the name of the file if it's a separate one. If it's a small CSS, just include it here in line. So, and inside you have code. So basically you have class, and inside you write constructor, you write methods, and so on. This is TypeScript. Now let's talk about TypeScript. I'll give you like 5 minutes crash course on the language. If you look at this book, it's a pretty popular book. It's already in 2nd edition, and it's called Secrets of the JavaScript Ninja. But if you look at the picture, this is not ninja. This is samurai, actually. Why this happened? Because JavaScript doesn't have types, right? It couldn't catch this error in the compile stage, so it went in production. And it's too late, right? So that's why we want to use TypeScript, to avoid these kind of problems. So let's take a look at a couple of examples. TypeScript, first of all, it's a superset of JavaScript. What does it mean? It means that you can take a file with extension JS, JavaScript program, rename it to TS extension, and it's already a TypeScript program. You can compile it. Why would you want to compile a program written in JavaScript? Because JavaScript has different flavors, right? What if you wrote it in ECMAScript 5 and now you want to compile it in ECMAScript 6? So it still makes sense to compile JavaScript with TypeScript compiler. Anyway, instead of var, it is recommended to use let. Let has several benefits, including you can declare a variable inside the code block, inside the curly braces, and it will not leak out or hoisted, as they call it. They have lambdas, like we do in Java. The only thing is, instead of dash, you put equal sign over here. So that's why they call them fat arrow functions. But technically, it's an anonymous function. Very similar to what we do in Java with lambdas. When you want to compile TypeScript into JavaScript, look at this. On the left-hand side, you see an example in TypeScript. On the right-hand side, you see what it compiled to in JavaScript. One of the great things about TypeScript is that it compiles into human-readable JavaScript, as opposed to many other compilers from different languages. A class. You write a class person in this case, and in there you write a constructor. This is not the only way to write it, but I show you the most concise version. In this constructor, I have 4 arguments: first name, last name, age, and SSN. So since I put access level qualifiers like public, private, protected, which exist in the language, it automatically creates for me class level variables or member variables. You don't need to write code over here and say this dot age equal age, or this dot SSN equal SSN, and so on. So it's automatically created for you, and you can use them right away. Inheritance. TypeScript supports inheritance, and it looks like classical inheritance. Take a look. Class person and class employee extends person, like in Java. The only thing you need to understand that this is syntax sugar. Under the hood, it's still prototypal inheritance like JavaScript has. Take a look at the amount of code it generated for this little piece of code. But syntax-wise, it's much easier to read, of course, and write classes. Generics. TypeScript support generics. In this example, I have class person, employee, and animal. And I have an array of using parameterized type, right, person. So I add new person, I add new employee, and I try to add new animal, and I'm getting compiler error. From the Java perspective, it's perfectly fine. Put anything you want in the array. But TypeScript gives you an error, which is very helpful, of course. Interfaces. TypeScript has interfaces. There are 2 ways of using interfaces. Some of them are, one way is to define the structure of the data, and the other one is our familiar interface, like a contract, implements, right? So interface IPayable defines one method, and class employee implements IPayable, class contractor implements IPayable, and we can declare an array, and again, using generics of that IPayable. And for each, we iterate through this collection of type interface. Interesting thing is that interfaces don't exist in JavaScript. So during the compilation, they are evaporated. They are vanished. You don't see any interfaces on the right-hand side. It's just for you, for your convenience. Now let's talk about Angular CLI. By the way, this was all you need. This is all you need to know about TypeScript to get started. Angular CLI, command line interface. Like about a year ago, people who started working with Angular 2, they often complained that there is too much to configure. You need to configure TypeScript compiler. You need to create package.json and download a lot of dependencies from npm repository. You need to configure build system, test system, and so on. So the tool was created to simplify all that. So to create a new project is pretty easy now. Angular CLI is not only a generator that will create you a starting project, but it also includes the build tool, Webpack. It also includes and configuration and the libraries themselves. Jasmine for unit tests. It includes Protractor for end-to-end tests. And you have the project immediately, not immediately, in 30 seconds you have a working project. And using Angular CLI, you can easily create builds for dev, for prod, optimize, not optimize, and so on. And let's try to do something like this. Let me generate a new project for you. I'm in the directory devox. Let me get there real quick. So I'm in this directory. ng is a command for Angular CLI, after I installed it, of course. I want to create a new project, my app, for example. And since I'm using version 4 of Angular, I will add a key -ng4. And it'll take probably like 30 seconds, and depending on the internet connection, of course. Now it's downloading tons of stuff, but when it's done, we'll get a project. We'll get a project. Actually, all these files are already generated. At this point, it installs dependency. There is a popular package manager npm that many people still use, but there's a better and faster package manager called Yarn. And I am using Yarn, as you can see down there. It is installing it using Yarn. Let me see if I have internet connection. It should be done by now. Let me see. CNN.com. Apparently there is a problem with internet connection. Let me try it, turn it off and turn it on, unless CNN.com is out of business. Yes, now it's back. So now I guess it'll continue. So, you know what, let me do this. Let me do it one more time. I don't know in which state it is it in because of that. Let me do another project, my app 2. So this time it'll work properly. In 30 seconds it will be ready. When it'll be ready, I'm opening it in the IDE. I don't have to. I can run it right from the command line, but of course we want to see what's going on over there, so I'll be using WebStorm to open this app and I'll show it to you. The app consists of subdirectories, src directory, app, and every component that you will create is a directory. That directory will have TypeScript file, HTML file, see it's done already, and it'll have CSS file, and what else? HTML, CSS, TypeScript file, and the file for unit tests, the spec file. So let me open it up in my IDE, this new project that I created. File, open. It is in Devox my app 2, that's the one. I'll open it up and you will see what was generated. And again, it's not only generated the project for me, it also installed all dependency, and there is a lot of dependency out there. So that's the project. That's the project. And if I open it up, you see that there's a src directory. It generated for me a small application and tons of configuration. So, for example, package.json is the one that configures all dependencies that I need. As you can see, I'm using version 4 of Angular. Angular component is right there. It just generates for you app works. It generated HTML, CSS, and they are right there. HTML file, for example, just has this little header. So what I will do now, I will build this app. I will bundle it up. Your application may have multiple files, hundreds of files. We don't want to deploy hundreds of files. So we want to bundle them up into a small number of files. To do that, I'm using, again, Angular CLI. So for example, I'll do ngserve. At this point, it'll bundle up this application in memory, and it'll start the servers that comes with Angular CLI, but actually it's a Webpack dev server. It'll start it and it'll run it in memory. This is how you work. See, bundles are already created. So if I'll go now to localhost port 4200, then I'll see my application working. See, it works. So the application is up and running, and you created it in no time. And this is how you work in development. The bundles are built in memory, and if I will go back to the app and I will change it, I will change the code. For example, this is app works, and I will change it to Devox works. Devox works. Look at this. I hit save, control save. It's recompiled, rebuild the bundle. If I'll go back to the browser, it's already recompiled and rebuilt it. This is how you work in dev. But this code is not optimized. I mean, the size is large. It's probably like 2.5 megabytes of code now. Came through the wire. If you want to optimize it, actually, let me show it to you. Let me open up DevTools in Network, refresh, and you will see not too many files, but 2.5 megabytes of code. It was downloaded. In dev mode, it's fine. I work locally. Everything is local, and connection is fast if need be. Now, if I want to optimize it, I wouldn't be using ngserve. I'd be using ngbuild. ngbuild, and with a key prod, ngbuild --prod. This time, it will not be creating in memory the bundles. It'll actually spit out the file that I can deploy somewhere on the server, where I'll show you. Basically, it'll be deployed in the same place, whatever Java server or any other server you use, where would you put index.html? If you know that place, this is where you put all the bundles, including index.html. So now it created a folder called dist, and if I will go there, if I will go to that folder, dist, you will see that the sizes are much smaller now. See, now I have 304. This is bundle for the framework itself, vendor bundle. My application is really small, main bundle, 9 kilobyte. But if I would gzip them, they would be, typically this application is under 100 kilobyte deployed and optimized. Let me go back to my slides. Single page application is where Angular shines, of course. And what is single page application? The page is not being reloaded. You start the page, you have certain areas on the page which stay all the time, but you define an area in the, called router outlet, and this area is where you want to put changing content. Say the user will be clicking on the links, and inside the router outlet you want to display different components based on the user actions or maybe based on some programmatic actions. So there is special tag router outlet, and this is what you do. This is where you define the UI. Router itself, again, I'm talking about client-side router. We talk about client only, navigation within the client. Client-side router support multiple useful features. For example, when the user moves from one place to the other by clicking the links, maybe you need to pass some data while you are navigating to a particular route. You can pass the data. You can have routes configured in the parent component and in the child component. So you have links in the parent and links in the child. You can use something called guards. So the user can click on the link. Actually, can the user click on the link? Is he or she allowed to click on the link? So you can put guards. For example, the user clicks and you just assign the guard and it checks. If the user is not logged in, you don't allow to go there. Lazy loading of modules. When you will be deploying applications, you will be deploying modules. And if you have some codes in your app that does not require to be loaded initially, whenever you start your application, there is no need to load it. You can create a separate module, and it'll be loaded only if the user will click on that link. So this will minimize the amount of code that comes to your landing page when you first load the app. So router is a really powerful component in Angular. Dependency injection. Everybody knows what's dependency injection, and the benefit framework in this case, Angular, would inject services for you. What is a service? It's a class. All business logic that you want to put in your app, you would put in a class. And instances of these classes will be created by the framework, and they will be injected into components. What is a component? Component is a class with annotation, a class with UI, where a service is just a class. Here is an example. We have a simple service. I have a class called ProductService, and I have a function called getProducts inside, and it returns me this hard-coded value. Typically, I would put HTTP requests over here to go and grab the data from some server. But in this case, I'm just hard-coding the data. So what do I do with it? Now I have a component, product component, that needs to use product service. So what do? I want to inject my product service into product component. How do I do this? In Angular, you do this only through one area, through constructors. So constructor is a constructor of this class, and just the fact that I declare an argument, product service, and in this case I declare the type, and they call it token, it tells Angular, in this case, find the class product service, create an instance of it, and inject it into this component, so it will be using it. So in this case, see, I never said new product service, I start using it immediately. I invoke getProduct on the product service, I assign it to a variable in the class. The variable is bound to the UI. The product object is bound to the HTML here, here, and there. And this is how, by using binding, as soon as the variable products will get the data, the UI refresh automatically through binding. In this case, we are using double curly braces to denote binding. In this case, I inject just an object built on the class, but you can create a factory and say, I want to use the factory to generate objects, or you can inject a single value as well. All that is supported in Angular. The other really powerful thing in Angular is its reactive part, RxJS, that is sitting inside the framework. And I'm sure even in this conference, you probably attended at least one talk about reactive programming in one or the other application or framework. RxJS is a library that comes with Angular. It's about pushing data. Instead of iterating over collections, instead of polling data, instead of bothering the server multiple times, do you have something for me? No. Maybe now? No. And now? No. So you get the data pushed to your client whenever it's ready, instead of you polling. So there's a concept like observable, which is a data pusher, so to speak. There is an observer, the object that knows what to do with the data when it comes in. And there is something called subscriber. Subscriber brings together observable and observer. Pretty nice and simple API, and very, very powerful operators that you can chain before the data comes to the subscriber. You can transform the data nicely by the time they come to the subscriber. I don't have time to talk about Rx. I spoke about it yesterday, but I can tell you that inside Angular, they use it a lot. You can use it, of course, the way you want it, but they already use it. For example, you can subscribe to the router object to get the changing data upcoming to this component shown by the router. When you create a form on the UI, you can subscribe to data that the user types in the fields of the form. Or you can subscribe to the status of the form. It was not valid, now it's valid. And the signals, the data will be pushed to you. Any HTTP response that you make comes back as an observable, and you subscribe to the result of HTTP. If you want to create WebSockets, you can create a class in TypeScript in Angular, and you can connect to the WebSocket on the server side, and the server will be pushing data to you, to your class, and this class, in turn, will be pushing data as observable. So you still use the same style, subscribe, subscribe, subscribe. And now let's take a look at this example. HTTP, how do you use HTTP in Angular? HTTP is an object that comes with Angular. It's a separate module. If you decide to work with HTTP, you include it to your app. And first of all, let's take a look. Class, app component. And in this case, I'm saying I need HTTP. I'm planning to work with it. How do I say that? I just declare an argument in the constructor. That's all I need. HTTP with a small h of type HTTP with a capital H. Just the fact that I use private qualifier in this case means that a variable this.http will be created for me, so I can refer to it from other methods in my class. So what do? I say this.http get. I want to make a get request to some REST endpoint. Get API products. When the data comes back, I want to extract the JSON out of it and turn them into regular JavaScript objects. So what do I do here? I extract the JSON, and then I say subscribe. Only when I say subscribe, the data will start, a request actually is being made, and the data comes back. If I wouldn't say subscribe, I wouldn't have anything, even though it looks like I make a GET request. So what do I specify to the subscriber? 3 things. What to do with the data if it comes in. Second, that's the first function. When the data comes in, I want to assign it to the variable this.products. This.products is an array, and apparently array is bound to the UI to show some data. And error, if error happens, I want to print data on the console. And finally, the third function, the third callback, is what to do when the stream is over. So this is an observer. These 3 combined is an observer in my example. Intercomponent communications. Very important part, since this is a library of that your app consists of a bunch of components. They need to talk to each other. How? What's the proper way to arrange this intercomponent communication? It has to be done in a loosely coupled manner, right? So component A and component B should be able to talk to each other without even knowing that each other exists. How to do this? First of all, there is a clean API, so-called input and output properties on the class. If you have a class, say order component in this case, the class that knows how to place an order. An order for what? To buy some stocks. Who's going to give me the stocks? I don't know. I am a component. I just defined that somebody, whoever wants my parent component, whoever it happens to be, will be giving me quantity and stock symbol to buy. Right? So I annotate these two guys. This one is a variable, and this one is a setter. I annotate these two with at input annotation. So whoever wants, they will give it to me. I don't know who. It's none of my business. Who is that guy? Let's say you have a parent component, and in the HTML template of the parent, you say, I want to use order processor. See this? Selector order-processor. That's why I can use it in the parent with angle bracket order processor. And what do I do here? I am using binding again. This time I denote it with square brackets. I am saying take the value of the variable stock. Apparently I have a TypeScript class that somehow will get the stock and bind it to the order processor stock symbol. So this is how we pass the data inside through the input property. See, the code is clean. This guy has no idea who is going to give the stock, or in this case, I'm using 100 as a quantity. How a component can pass the data out without any tight coupling? Using events. In this case, we define last price, and we marked it with an annotation output, meaning that this is how we're going to send the data out. To whom? It's none of my business. I'm just a component. Whoever wants it, let them subscribe to it. So what do I say here? I declare a variable last price of type event emitter. By the way, event emitter is a subclass of the class subject in our X library, similar to what we do in JMS, for example, with topics. So I'm saying I'm going to be emitting a custom event called last price in this case, and this event will carry a payload of what type? Here's the type is I price quote. Apparently, I declared an interface, and I will be shooting out the object that are of this type. In this case, I am randomly every second I'll creating an object with random price, and I will be shooting it out. How the parent will get the data? Simple and unique, unified syntax. Parentheses. In Angular, in HTML, when you want to process event, you put the event in parentheses, being that standard DOM event or your custom event, regardless. So in this case, I read this line and I see, oh, I'm using price quarter component, great. And apparently, this component can dispatch an event called last price. What I want to do when the last price is dispatched, I want to invoke the function price quarter handler and pass this object to this price quarter handler. What will be in that object? Exactly what I defined in my interface I price quote. So no miracles or miracles there. You know exactly what's happening. And over here, I'm saying last price.emit. This is how you're shooting out the event to whoever wants to hear. Clean communication. How do you work with state? Say you want to have some class that remembers the state of your app. Of course, there are frameworks that allows you to do that in a fancy way, but in a simple way. If you imagine that you have an app. I use all these geometrical figures or shapes to illustrate that this how your app can be structured. You have a top component, then you have another container, number 2, which in turn has 2 components, 4 and 5. You may have another container, 3, which has 7 and 8, and 6 standalone. The components should know about each other. And how do you exchange data? Say number 5, the user was typing something in there, and this needs to be known inside the component number 6 and number 8. How to do something like this? You create a service, a class. You define in there a place to store this data variable or variables, right? and you inject this service into all interested parties. Like in this case, I would be injecting it into number 5, into number 6, and into number 8 components. Right? So number 5 then can put some value into the state variables inside, and it can fire an event. Number 6 and number 8 can subscribe to this event, and whenever it happens, if it happens, they will get it. So every time number 5 is changing the state, number 6 and number 8 will get notifications. Again, number 5, 6, and 8 have no idea that each other exists. Loosely coupled communication. Forms API. Actually, there are 2 APIs for working with forms. One of them is called template-driven API, and the other one is called reactive API. What's the difference? With template-driven API, you define the form right inside HTML, like on this slide. This is a form, for example, for the user registration form, user, social security, password, and so on. It looks like a regular form, right? But I want to handle it somewhere. I don't want it to send the request to the server as soon as I hit the button submit. It's a standard default behavior. So what do I say? First of all, I say, I want to intercept the submit event. This is how you do this, in parentheses and gsubmit. What do you want to do when the user hits submit button on the form? You want to pass the values that the user entered on the form for validation, maybe. So how do you do this? How do you grab the handles for the DOM object that represents the form? How do you find it in the DOM? Very simple. You define a local variable. In this case, I decided to call it f with hash sign. And this variable right there, it gives you a reference to the place in the DOM where this form was created. So if I want to analyze the values on the form, I say f.value. I pass it to my function on submit, and I can do whatever I want with the data. So the value will have an object with key value pairs. Each key will represent the field on the form. Very simple. Reactive forms, on the other hand, allows you to define a form in TypeScript, not in HTML, but in TypeScript. You have to program more, but you have more flexibility. Now, deployments. Let's talk about deployments. It's an important part. How do you deploy? There are different packages to deploy, like Grunt or Gulp are popular in JavaScript world, but there is a simpler way that can serve most of your needs in deployment. So it's called npm scripts. In package.json, you have a section. If you have a section scripts, you can define commands that you want to run. You can run these commands like start. It's like an alias. The start command is an alias to ngserve and this long line. Or ngbuild. Instead of typing ngbuild -prod, I could have typed npm run build, and so on. Moreover, this system is pretty smart. Why it is smart? Because it uses prefixes and stuff, prefixes like post and pre. And let me explain you how this script works. But first of all, what does it mean to deploy? We need to build the bundles, right, using Webpack or ngbuild. And we need to copy them into a certain destination. If something was there from the previous deployment, we want to delete it, delete the directory, all subdirectories, and copy a new version. That's it, right? This is what you do, regardless of what language you use. So let's see what I can do. I can do ngbuild, right? ngbuild will run this command. This command will create bundles for me in a directory dist by default. And npm script is smart enough to see, oh, actually there is a post build command as well, which means I must run it right after the build. It'll run it automatically. What do I want to do? I want to run npm run deploy. Oh, there is a command deploy, yes, but there is also command pre-deploy, right? So it won't run this deploy command. It first will run pre-deploy, which what do we do in there? Rimraf is this little utility that knows how to delete directory and subdirectories regardless of the platform. Works for Windows, Linux, Mac. So I want to remove stuff from the server build public in this case. mkdirp, again, it's a cross-platform utility that knows how to create a new directory. And then I do copy files from my this directory where I build my bundles into this directory. That's it. Deployment is done. I guess I have time. I will show it to you how this works. And now let's take a simple example with Spring Boot. I created a really simple Spring Boot app with an endpoint that returns me 3 hard-coded products, right? And I want to create a consumer in Angular and deploy it under Spring Boot, right? So this is the code. I'll show it to you in the IDE now. This is the code that I have in Spring, product controller and simple product. But Angular code, I'll build it in my directory, dist, and then I want to make sure it gets copied over here. If you put static resources, which is the HTML, CSS, JavaScript, inside the resources static, then you are deployed. The deployment in Spring Boot is done. So now let's see if we can run it real quick. So this is my app in Spring Boot. What do? I created a product controller. I said that whenever the request comes with API in the URL, it has to come to this class, right? And what else? What else do I say? Also, I say whenever there will be a word product after the API, I want to invoke this method. This method get products. It's supposed to return products. Where are the products? This is my database, an array of products, 3 products. So let me run this little app. And by the way, as of now, it doesn't have anything deployed, so directory static is empty. That's why when I will run this server, Spring Boot, which comes with Tomcat, it automatically will start the Tomcat for me by default, and it runs on port 8080. If I will just go to my browser, and if I will go to localhost port 8080, I'm going to get an error. Why I'm getting an error? Because I didn't do the mapping for the endpoint if there is nothing after the server side, right? But if I will do /API/product, which I did mapping for, then I'm going to get my JSON, right? So that's the guy. So my server works, but there is no UI, no consumer, no Angular consumer just yet. Let us keep it running, and let's go to the Angular app, which is not that one. I don't need this one anymore that I generated. This one is probably the one, Spring Client, right? So what do I have in this app? It's, again, also a very simple app, which has one component. And what do I do in here? I'm saying run HTTP GET to API products, right? And when the data comes back, subscribe. And if it's an array, then assign it to the variable data. Otherwise, add a new element to the data. And the products will get the data. The products is an array. And in the HTML, in Angular, I have an G4, which loops through the elements, in this case, of the products array, as many as they are over there, and it will repeat this piece. It's an unordered list, and it will repeat the piece li as many times as I have elements in the product. That's it. So if I will run this as a gserv on my dev machine, I will create a situation which is kind of interesting. I will be running my dev server on port 4200, right? On the other hand, I'm running Spring Boot on port 8080, right? So we have a situation, a conflict situation with with the same origin policy. I cannot make a request from this app, from my app that runs on port 4200 to the other port that is running somewhere else. So in this case, if I will check the error, it'll tell me that it couldn't find the API product. There is no resource on port 4200, which is correct. My Spring Boot runs on port 8080, right? So what do we do? So what I can do, I can define a proxy. There are different ways of doing this, but I can define a proxy right there, saying whenever you see an API in the URL, redirect it actually to the port 8080. So how to run this with a proxy? I can type this command, the whole command manually to say where this proxy file is, or I actually configure the command start, which will do it for me, the whole ngserv like that. So what I will do, I will run npm start, and it will run ngserv with the proxy. It'll build again the bundles in memory. And when it's done, I'll hit the same URL, localhost 4200. And they are here. See? These guys came from the Spring Boot container. Now, I have a situation in the dev mode. I'm running 2 servers. It's convenient for me to run dev server to build all the UI in memory, right, using this Webpack dev server. But realistically, when I'm done, I want to deploy this stuff, right? So I want to deploy my bundles under the Spring Boot container, correct? So this is exactly what we will do now. And it's pretty simple. Coming back to the NPM script section, look at this. These 4 commands. I will run npm run build, which will build the bundle for me. After this command is done, you will see a directory dist over here in the UI part. Then it'll run deploy and pre-deploy. In pre-deploy, it'll remove stuff from here. Look at this, server, src main. This is my Spring Boot guy. Let me show you the directory structure that I have. I have this devox, and I have this Spring directory, which has 2 subdirectories, client and server. Server is the app that I showed you. That's my Java app, Spring Boot. And this is the client. So I go 1 level up, and then to server, and where I need to be. Where is that? I go to server, src main resources static. So it'll remove anything if anything exists from previous deployment. It'll recreate the directory, and it'll copy files from my dist directory right there. So let me do this real quick. npm run build. It'll run build and post build and pre-deploy and deploy. If you will watch down there, you'll see it. Right now it runs ng build -prod. When it's done, it'll do pre-deploy and deploy. See, it's done. It did remref client, it did copy file. If I'll go to my Spring Boot project, look at this. I got stuff under static now. See? All the files, all my bundles from Angular will copy. That's all I need to do. Let me actually restart the server, the Spring server. Now I have a Spring Boot app with deploy Angular underneath. So when I will restart the server, I can just hit the port 8080, and I am expected to get my Angular app with 3 products properly rendered. Let's see. This one is port 4200, but I will do now 8080. And it works. So what we just did, we created a Spring Boot app. We created an Angular app. We deployed it. Pretty easy. Pretty easy. I don't have much time, so let me finish the presentation. And then if you have questions, you can ask me. Finally, look at this guy. It's a site that was created in 1995. And surprisingly, this site is still alive. It is horrible, and you would hate, right, to buy stuff on this site. But this is how things were done before. So people from Google decided to come up with some proper standards of how to design sites so they are pleasing to the users. They created a spec, material design, and different libraries started to implement it. For example, they created all these nice palettes. They gave all the numbers, saying that you can use this as a primary palette, and this is the numbers, and you can use these 50 shades of gray, or anything else. So the site will look better. They define how to do animations on the UI, how the button should look, and so on. Angular Material is a library that Angular team works on. It has already like 25 components, but it's not enough for a real-world application. So what we usually do, we start with Angular Material, really good quality components, and when we run into an issue, for example, it doesn't have a calendar control, and we need it, right? So we use third-party UIs for Angular. This is something that I could recommend you, PrimeNG. We tried another one, but PrimeNG is a good one. If anybody used to work with Prime Faces before, in Java server faces, that's the same guy from Turkey who created this library back for Java, and now he created it for Angular. I don't have time for the demo because I have 35 seconds left. That's this last slide. Take a picture. Up on top, there is a URL for this slide deck. if you care, if you want to download it, so you can do this. So thank you very much.